All right, so our first example that we're going to work is this one here. The absolute value of 5 minus 3x is less than or equal to 10. So I have an absolute value expression on the left, a positive number on the right, and I can rewrite this as a compound inequality. That's going to be my first step. Since this is a less than or equal to, the thing in the absolute value will go in the middle of my compound inequality, and on either side I will put this positive value and the negative of that. So negative 10 is less than or equal to 5 minus 3x is less than or equal to 10. Now, it is perfectly possible to work this all at once, but when people are first starting out, I find sometimes they make fewer careless mistakes if we break it up into the two inequalities that compose this one. So we subtract 5 from both sides, or subtract 5 gives us negative 15. And now I divide by negative 3. I'm going to be very explicit about what happens here. When I divide by negative 3, I change the direction of my inequality. So I have 5 is greater than or equal to x. So now we take the other side of our inequality. We subtract 5 from both sides of this inequality. Again, we divide by negative 3, and again I'm going to be very explicit about what happens. I'm dividing by a negative number, and so I need to flip my inequality sign. That gives me x is greater than or equal to negative 5/3. I can rewrite this as a compound inequality again. Now the smallest, the least thing, is the negative 5/3. That is less than or equal to x is less than or equal to 5. I was asked to graph this. So if this is 0, this is 5, and I'm not going to keep this exactly to scale, but to be roughly to scale. 5/3 is 1 2/3, so we'll put negative 5/3 here. These are less than or equal to, so I represent them with solid dots, and it's everything in between those two. You can use this notation, or you can use the other alternate notation. The alternate notation says we use square brackets when something is included. But again, this is from negative 5/3 to 5. And you can put the 0 on that number line. It's not strictly necessary. All right, our next problem is somewhere. Is here. So we have, we don't have our absolute value expression isolated yet. That's the first thing that I'm going to want to do. So for the very first thing, I will add 3 to both sides of this inequality. And then now I can rewrite it as a compound inequality. It is less than or equal to this positive number, which means the thing in the absolute value is in the middle of a compound inequality where I have 1 on this side and negative 1 on this side. The positive number from here and the negative of that here. I can do like I did before and rewrite it as 2 separate inequalities, or this time we'll go ahead and show you if we could add to 6 to both sides of this inequality. But remember, it's a compound inequality, so you would have to add 6 to this as well. So I would have 5 is less than or equal to x is less than or equal to 7. And this one didn't ask me to graph, but I'm going to go ahead and graph it. It's everything in between 5 and 7, and I do want to include those endpoints. Our next example is this, solve and graph the solution set, where we have 1/2 times the absolute value of 3x minus 1 is greater than 5. So here, I don't have my absolute value expression isolated yet. The first thing I want to do is get rid of this 1/2. I'm going to do that by multiplying both sides by 2. Since 2 is a positive number, I don't have to worry about flipping my inequality symbol. And now I have the absolute value of 3x minus 1 is greater than 10. I've got my absolute value expression on one side and a positive number on the other. So I can rewrite this as a compound inequality. This is greater than, so I have to rewrite it as 2 separate inequalities. So either 3x minus 1 is greater than 10, or 3x minus 1 is less than negative 10. One of those two things is true. So first, I will add 1 to both sides, and I'll get 3x is greater than 11. So x is greater than 11/3. And again, I divided by 3. I did not need to worry about flipping the inequality sign since 3 was a positive number. Over here, I'm going to add 1 to both sides. Negative 10 plus 1 is negative 9. I'll divide by a positive 3 and end up with x is less than 3. So I've got x is greater than 11/3 or x is less than negative 3. So there's my negative 3. Here's my positive 11/3. And this is 2 disjoint intervals. I do not want to use a solid dot. I want to use an open dot because this is strictly greater than. And it's greater than, so we go to the right. Or x is strictly less than negative 3. So I use an open circle around negative 3 and go to the left.